Assalamualaikum and good afternoon to all of my students. Hi, welcome back to our PDPR online classes. I hope all of you can focus and understand what we are going to learn later. So if you have any problem, please don't hesitate to ask your subject class teacher. Okay, so now you are watching the first video of new topic in our syllabus additional mathematics KSSM Form 4, which is chapter 9, solution of triangles. So there are 4 subtopics, but in this video I'm going to teach you subtopic 9.1, which is sine rule. 9.1 Sine rule. So by the end of this video, you should be able to make and verify conjecture on the relationship between the ratio of length of side of a triangle with the sine of the opposite angle, and hence define the sine rule. And then you should also be able to solve triangles involving sine rule, and lastly, you should be able to solve the problems related to triangles using the sine rule. So there are 9.1.3 and 9.1.4, which is related to ambiguous case, will be taught by Miss Muslima in the upcoming videos. Okay, the first subtopic, making and verifying conjectures on the relationship between the ratio of length of side of triangle with the sine of the opposite angle. In our daily life, we often face situations involving triangles. For example, the solution to find the height of a kite. When it involves a non-right angle triangle, Pythagoras theorem is unsuitable to be used. Okay, so in this diagram, we want to find the height of a kite. Okay, this is a non-right angle triangle. Okay, there are other methods to find the solution of non-right angle triangle. So let's explore. Okay, let's do inquiry 1 activity. You can refer your textbook on page 242. Okay, so this activity aims to make conjecture on the relationship between ratio of the length of side of triangle with the sine of the opposite angle. So there are two types of triangle here, which is the first one is acute angle triangle and the second one is obtuse angle triangle. So there are 6 box that you need to fill in. So you can refer to this formula: A sine A, B over B sine B, and C over sine C. So this is the ratio of length of side of triangle with the sine of opposite angle. So for the first triangle, so where is A? So A here is located in the opposite to the angle of the vertex A. Okay, so small a refer to the length of side of triangle and big A refer to the angle. Okay, and then for this one, 9.8 is the B, which is small b, located opposite to the vertex B. And lastly, okay, this one, length of side of 7.46 is the opposite to the vertex C. So you have to fill in the values according to these formulas and try to find the answer. Okay, but I already did it for you. So the first one, okay, 11.12, so the red color, okay, divide by sine 78.93, so you will get 11.33. Okay, while for B, which is the yellow color, 9.8 divided by sine 59.89, you will also get 11.33. And lastly, the green color, the length of side for C, which is 7.46, divided by the sine 41.18, you will get 11.33. So now let's do for the obtuse angle triangle. Okay, so where is small a? Small a is located the opposite to the angle of vertex A, which is 8.5. And where is B? Small b. So here B. Okay, since it is located to the opposite of vertex B. And lastly, this one is C, since it is located to the opposite of the angle of vertex C. Okay, so try to find the answer. Okay, so 8.5, the red color, okay, divided by sine 46.3, you will get 11.76, and then 4.06 divided, you will also get 11.76, and lastly you will also get 11.76. From the result of inquiry 1, it is found that the value of A over sine A is actually equal to the value of B over sine B, and also equal to the value of C over sine C, or the value of sine A over the length of A is actually equal to the value of sine B over length of B, and lastly sine C divided by C, length of C. Okay, so so if we draw a diagram, so this is the triangle. So this one is A, B, and C. Okay, so this one is A, B, and lastly this is refer to C. So is this conjecture valid for all types of acute angle triangle and obtuse angle triangle? So let's explore. Diagram A and diagram B is an acute angle triangle and obtuse angle triangle respectively. So this is acute angle triangle and this is obtuse angle triangle. So CD is perpendicular to AB, which is 90 degree and represented by H, and also this one CD is perpendicular to AB, represented by H. So in lower form, you still remember that you have learned trigonometric ratio, sine, cos, and tangent. So the formula for sine is the ratio of length of the opposite side divided by the hypotenuse, which is SOH. So, okay. So refer to the triangle BCD. So here, triangle BCD here. Okay, B. Let's see for the vertex B. So sine B is equal to, what is the opposite side of B? It is H. Okay, label with H. And hypotenuse. Hypotenuse means the longest side of the triangle, which is A. Okay, this is the hypotenuse. That's why we get H over A is equal to sine B. So then H, make it H as subject, H is equal to A sine B. So this is equation number 1. And then consider the triangle ACD. Okay, this one. Okay, I will use the other color. This one, ACD. So let's say A. Okay, so sine A is equal to H over B. So here, okay, so H is equal to B sine A. This is equation number 2. So 1 is equate, you equate with 2, the equation number 2. So A sine B is equal to B sine A. So this one is H. Okay, H equal to H. This H is A sin B and B sin B. So make it as a ratio. So A over sin A is equal to B over sin B, or sin A over A is equal to sin B over B. So it is observed that for any acute triangle and obtuse angle triangle, the ratio of length of side with the sine of the opposite angle are the same. This relationship is known as the sine rule. Okay, you can also refer your textbook page 242 of 243. Okay, there are this QR code, or you can go to this link. Okay, to see the relationship between the ratio of length of side of a triangle with the sine of the opposite angle by using the GeoGebra software. So, if you want to explore whether the conjecture is valid for all types of acute angle or obtuse angle triangle, so you can try this QR code. So, I try this QR code, and it goes to the link of the this GeoGebra. So let's see the movement. So if I drag the vertex A, the size of angle is different. So we can see that here the ratio is always the same, no matter how I change the vertex A, B, and also C. Okay. So in conclusion, this is the formula for sine rule for any triangle ABC. So the value of A over sine A is equal to B over sine B is equal to the value of C over sine C, or sine A divided by A is equal to the value of sine B over B is equal also to sine C over C. Okay, example 1. Write the sine rule that really the side and angle of the following triangle. Okay, so we have two types of triangle here. Okay, so how to write it? The solution, the first one, D over sine D is equal to E over sine E, F over sine F. So this one, the length of D is the opposite to the vertex, the angle of D. Okay, and so on. Okay, this one. Okay, and also the solution for B is this one, H over sine H is equal to J over sine J is also equal to K over sine. Okay, we move to the next subtopic, which is solving triangle involving sine rule. Solving a triangle means finding the measurements such as length. Okay, finding the measurements such as length, size of angle, or perimeter, or area of the triangle. Okay, example number 2. Find the value of x in the following triangle. So, how to find x? So, x is the opposite angle is 48. Okay, given 14.3, so the opposite is 80 degrees. So, refer to the sine rule. So, we can write as x over sine 48 is equal to 14.3 sine 80 degree. Okay, so how to find x? So x is equal to 14.3 divided by sine 80 degree. Okay, multiply. So this one divide and then become multiply with sine 48. So you press calculator, you will get the answer is 10.791 cm. Okay, let's move to the second question. So we want to find the size of angle of x. So before this, I use the formula A over sine A is equal to B over sine B. So now, since I want to find the size of angle, so I will use the formula of sine A over A is equal to sine B sine B over B. So the solution. Okay, so x, the opposite length is opposite side is 7.05, while vertex x of the angle of 55.5 is the opposite is 6.2. So let's write sine x over 7.05 is equal to sine 55.5 degree divided by 6.2. So how to find sine x is equal to sine 55.5 divided by 6.2 multiplied with 7.05. So you press calculator, you will get sine x is equal to 0.9371. So you are not done yet, since you only get the value of sine x, not the size of angle of x. So how to find the size of angle of x? So sine, it becomes sine to the power of -1, 0.9371. So if you want to press calculator, you press a shift sign, you will get this one. Okay, so sine to the power of -1, 0.9371, you will get the answer as 69.57 degree. So this is the size of angle of. Okay, let's move to example 3. Diagram below shows the position of Christina House, Ron House, and a post office. So for question A, calculate the bearing of the post office from Christina House. So flashback in geography, bearing is used to indicate the direction of certain place from a reference point. Example, this one. So bearing A from O in the above diagram is 30 degrees. So it's referred to this angle. So not this angle. Okay, so you have to be careful when question asks for bearing. So bearing of the post office from Christina. So let's say for this I write the post office as P, Christina House as Q, and Ron House as R. So the solution, so how to find it? So Q, the opposite side is 9.4. So given also the post office 98 degree, so the opposite side is 12 kilometers. So we write as sine Q is over 9.4 is equal to sine 98 degree over 12. Okay, so sine Q, sine 98 degree over 12, you multiply with 9.4, so you press calculator, you will get sine Q is equal to 0.7757. So how to find Q? So shift 0.7757, so you will get the answer as 50.87 degree. So this is the size of angle of Q here. Okay, so by the question asks for bearing, bearing refer, okay, of the post office from Christina House refer to this angle. Okay, so we have 90 degree and we have the value of Q. So how to find the bearing? So bearing P from Q is equal to 90 degree minus with 50.87 degree. So you will get the answer as 39.13 degree. Or you can also write as the bearing is 039.13. Okay. Okay, now let's move to the same question. For question B, ask for the bearing of the post office from Ron House, and question C, ask for the distance from Christina House to the post office. So just now we already labeled post office as P, Christina House as Q, and Ron House as R. So smartly, if you want to solve triangle using the sine rule, okay, the following condition must be linear. So if we want to use sine rule, there are two angles and length of one side is given, or there are two length of a length of two sides and a non-included angle is given. So non-included angle refer to the opposite angle. Refer to the opposite. Refer to the opposite and how to write this? Opposite angle. Okay. Of the given side. Okay, so now let's solve for question B first. The bearing of the post office from Ron's house. So R. Okay, so we want to find the bearing. So we need to know the size of angle R first. So R is equal to 180 degree minus with angle of P and minus with angle of Q. So 180 degree, so you minus with 98, we minus with the angle Q just now is 50.87. Okay, we calculate in the first question. So we get the answer is 31.13 degree. So this is not the bearing. So remember the bearing. So the bearing start from this line. So since R located here, so the bearing should be okay from this one to this one lah. So this one is 90 degree. Okay, this one is 90 degree. This one is 90 degree. And this one is size of R. So means that to find the bearing of post office from Ron's house, so it is equal to 270, 90, 90, 90. So you get 270 degree. You plus with 31.13 degree. So you will get the answer as 301.13 degree. So this is the bearing of post office from Ron's house. Okay. So this is for question B. So now we want to solve for question C. Okay, the distance from Christine house to the post office. So this one. Okay, and let's say I label as R. Okay, you can write this as PQ or any letter. Okay, since this one, the opposite angle is big R, so I label as small r. So if we want to find R, okay, so sine, okay, what is the angle of R? R is 31.13. Okay, is equal to, what is another length and angle given? So here 12 with 98. Okay, so 12 over sine 98 degree. So you will get R is equal to 12 over sine 98 multiply with a sine 31.13 degree. Okay, so you will get a 6.265 kilometer. Okay, kilometer. M. Okay, so the distance from Christina house to the post office is 6.265 kilometer. Okay, let's move to the last subtopic, which is solving problem related to triangle using the sine rule. Okay, example 6. Okay, Azian and Christine stand straight in front of a flag post as shown in the diagram. The elevation angle of the top of the pole from Azian is 36 degree. Okay, here, so you have to highlight the important point. So the elevation angle of the top of the pole from Azian is 36, whereas the elevation from angle of the top of the pole from Christine is 50 degree. Okay, Badrul is standing on the left side of the flagpole and the elevation angle of the top of the pole from him is the same as Christine. Okay, same Badrul. Okay, same as Christine, the elevation angle. So the distance between Azian ASEAN and Christine is 35 meter. So find the distance between ASEAN and Badrul if the height of the three of them are the same. Okay, so if you want to solve this one, so you have to use a triangle sign rule, refer to that as. So you need to draw a triangle before you solve using the sign rule. Okay, so the solution. So first, let's represent the position of ASEAN, Badrul, Christine, and the top of the pole with A, B, C, and D respectively. Okay. So let's say this one is ASEAN as A, this one is B, the Christine as C, and this one is D. So if you want to draw triangle, okay, it is like this. Okay, so the triangle is like this. This is the top of the pole. D is the top of the pole. A refer to the ASEAN. B Badrul, C Christine. So elevation angle from Christine to the top of the pole is 50 degree. Badrul is same as Christine, which is the elevation angle also 50 degree, and ASEAN the elevation angle is 36 degree. So the distance between ASEAN and Christine is 35 meter. So this is how we label the solution, the question into a diagram. Okay, so this is the diagram just now. So we want to find the length of AB. Okay, in order to find AB, given 35 meter here is the length of AC. So we need to know what is the length of BC. So since we need to know what is the length of BC, so of course we need to know what is the size of angle here, D. So the first one, by refer to the red color here. So this is the angle, okay, and then we also need to find the opposite angle for 35 meter, which is this angle, the yellow color. Okay, so first let's find the angle of ADC. Okay, the yellow color. Okay, sorry, okay. So the angle of ADC is equal to 180 degree minus with 36 degree, minus with 50 degree, so you will get as 94 degree. And then the blue color, the label blue, if you want to find this one, okay, I write another color, which is angle of BDC is equal to 180 degree minus with 50 degree minus with 50 degree, so you will get 80 degree. Okay, so now we can find the length. Okay, let's say I want to find the length of DC first. Okay, this one, DC. Okay, so the angle given is 36. Okay, also we have another angle which is 50. So no matter, so we want to use the big triangle first. Okay, to find DC. So DC ratio to sine 36 degree is equal to, okay, what another angle given here is just now this one. Okay, angle ADC refer to the length is 35. So sine 94. Okay, so DC is equal to 35 divided by sine 94 multiply with sine 36 degree. So you will get the length of DC is 20.6227 meter. Okay, and then we need to find BC in order to find AB. So how to find BC? So BC over sine 80. Okay, this one, the angle blue color here just now. Okay, refer to the opposite length is BC. So sine 80 degree is equal to, okay, just now we already get 20.6227. Okay, please refer to this triangle only, the small triangle. Okay, sorry. Sorry, okay, refer to the small triangle. Okay, I highlight this. Okay, so 20.6227 divide by, divide by sine 50 degree. Okay, since I refer to the a small triangle. Okay, so BC you will get the answer as, okay, 20.6227 over sine 50 multiply with sine 80 degree. So you will get BC as 26.5120 meter. So how to find BC? BC is AC, you minus with BC. Sorry, not BC. This one is AB. Okay, AB is equal to AC minus BC. So AC is 35. BC is 26.5120. So you will get AB as 8.488 meter. So this is the distance between ASEAN and Badrul. Okay, so that's all the example of the sine rule and also the example on how to solve the problem related to triangle using the sine rule. So as your exercise, okay, you already bought this book, which is module part 21, okay, the black workbook, Nilam publication. So you need to do unit 9 solution of triangle, exercise 1 page 172, and then exercise 2 page 173 and 174, and lastly exercise 4 page 178. You don't need to do exercise 3 because it is related to ambiguous case which we haven't learned yet. So you need to do it later. Okay. So that's all for today's class. Thank you. In the next class, you are going to learn 9.2, which is cosine rule. Okay. Bye bye. Assalamualaikum.